This is section 6, derivative rules, example 3. So now that you know the power rule, you need to know how to do it if there's something in front of your function. So for instance, in part A, we have 2x instead of just x. So we're going to still apply the power rule, and whatever exponent we bring to the front, we're just going to multiply by whatever we would get. Okay, it's actually not something you have to memorize or really think about once you're used to taking derivatives. It actually becomes very intuitive. So let's look at A. The exponent for A is 1. So we're taking that 1, we're moving it to the front and multiplying it by 2. Well, 1 times 2 is just 2. We remove 1 from the exponent, so 1 minus 1 would be 0, which means we have x to the 0 power, which is just 1, so y prime is just 2. Another way of thinking about this is that if you have a number in front of x, the derivative is just the number. Okay, so try not to overcomplicate those types of problems. For part B, we're taking that 3 and moving it to the front. Well, if I have 3, let's not put it there. If I have 3 times 4/3 x, and then we have, instead of 3, 2, because it's 3 minus 1, as our derivative, then those 3's cancel, and we just get 4x squared, right? Which is very simple. So from now on, instead of writing it like that, I'm just going to do the math automatically. For part C, we're taking the 5, moving it to the front. 5 times negative 1 is negative 5t. We're subtracting 1 from the exponent, so we get 4. So s prime of t is negative 5t to the 4th power. For part D, just like part D on example 2, we need to take this square root and change it dx to the 1/2. When we do that, we're going to multiply 4 by 1/2. Remember, we take our number, we put it to the front. Now because there's a number 4, we're multiplying. 4 times 1/2 is 2. So y prime ends up being 2x, and then instead of positive 1/2, we're getting negative 1/2 because we're going to subtract 1. Now, from here on out, I'm just going to leave negative exponents as negative exponents. Because again, on the AP test, they do not require you to simplify exponents if you don't need to. In part E, we need to take our exponent and again move it to the top, just like before. So we actually have 5/3 times x to the negative 3rd power. We are taking the exponent and moving it to the front. Now 5/3 times negative 3 cancels out those 3's. So all we end up with is negative 5x, and then negative 3 minus 1 is negative 4. For example F, it looks very similar to example E. However, there's a parentheses around the 3x, which means instead of negative 5 over 3x cubed, we actually have negative 5 over 27x cubed. And so that needs to be rewritten as negative 5 over 27 times x to the negative 3rd power. Now we take the derivative. So f prime of x means that we take the negative 3, we multiply, the negative times the negative will make that positive, and 3 over 27 is 1/9. So we end up with 5 over 9 times x to the negative 4th power. For G, we're going to rewrite that also. We would rewrite that as 40t to the negative 1/2 power. Remember, the negative 1/2 is because it's in the denominator and it's a square root. We take the 1/2, we move it to the front. 40 times negative 1/2 is negative 20. And negative 1/2 minus 1 is negative 3/2. For this last example, we're rewriting this as 12 times x to the negative 5/3 power. It's 5/3 because 5 is the exponent and 3 is the root. Remember, for the denominator to exist, you would have to have a root. Otherwise, it would just be x to the 5th power to begin with. Okay, it's the root that gives you the denominator for your rational exponent. Now we're going to take the negative 5/3 and multiply it by 12. Well, if I multiply 12 by 1/3, we end up with 4. So that's actually negative 4 times 5, which is negative 20. And we're taking negative 5/3 and we're subtracting 1, so we get negative 8/3. And that's the answer.